Thus far we've talked about Lewis structures of neutral molecules, and now we're going to talk about the Lewis structure of charged molecules. And in reality what we're going to find is really not the overall molecule is charged, but an individual atom or atoms inside of the molecule is charged. The first thing we want to do is to be able to identify atoms that have a charge. So we need to be able to determine what the charge is on an individual atom. To do this, we use this equation, which says that the formal charge on an atom is equal to the number of valence electrons on that atom minus the number of electrons that are as lone pair electrons minus 1/2 of the number of electrons in bonds. So if we want to apply this and we say what is the charge on oxygen in the following molecules, we look at this one. The formal charge is going to be equal to the number of valence, so oxygen has 6 valence electrons, minus the number of electrons in lone pair electrons. So remember, each one of these is paired, but in total there is 1, 2, 3, 4 electrons as lone pair electrons. And then we take 1/2 of the number of electrons inside of bonds. So this oxygen has 2, 4 electrons as part of a bond, so we take 1/2 of 4. When we do the math, this individual oxygen is neutral. And this kind of makes sense if you think about it. Each one of these bonds is sharing electrons, so the electrons are part way between hydrogen and oxygen, so that's why there is a 1/2 in this part of the equation. So if we look at this oxygen, same thing, 6 valence electrons on the oxygen. The number of electrons in lone pairs are 1, 2, 3, 4, 5, 6, so we subtract 6. And here we only have 2 electrons as part of a bond. And remember, we take 1/2 of that. When we do the math, we understand now that this oxygen actually has a negative charge. Now what we want to do is to be able to draw a Lewis structure with a charge already inside of it. So also remember that if you sum all the formal charges of atoms inside of an individual molecule, it must equal the overall charge of the molecule. So remember, it's individual atoms which have charge, but say I have 2 positively charged atoms and 1 negatively charged atom. If we add it all together, our overall molecule would just be +1. So remember, we need to add together all of the formal charges of the atoms to determine the charge of the overall molecule. But in this case, we really want to focus on the charges of individual atoms when we're trying to draw the Lewis structure of charged molecules. When we go into drawing the Lewis structure of charged molecules, it's most convenient to make an assumption that a negative formal charge on a molecule is probably going to be on the most electronegative element. And so this makes sense. This is a measure of electronegativity, means that it likes putting electrons on itself. So this is a pretty safe bet that if a molecule has a negative charge, the negative charge is actually going to be on the most electronegative element. And the opposite is true. A positive charge is usually on the least electronegative element. So this is not always true, but it's a good way to start. If this doesn't work out, another one is that charges tend to be on central atoms. So with drawing Lewis structures, you might have to try a couple of variations, and these are rules that can get you started towards trying to find the correct Lewis structure. The Lewis structure of a charged species can most easily be found by anticipating which atom contains the charge on the molecule, and then either adding or removing electrons to create the charge on that individual atom. So we want to add or remove electrons from the initial Lewis symbols before we start combining them together to create a Lewis structure. So here's an example where we ask to draw the Lewis structure of H3O+, and in this case we know that the oxygen is going to be gaining a positive charge. So what I want to do is start with the typical Lewis symbol for oxygen, which has 6 valence electrons, and I want to give it a positive charge by removing an electron. We put the electrons around oxygen as if it has only 5 electrons. And you're going to see that as we change the charge, we change the bonding properties of the individual atoms themselves. So here, oxygen with a positive charge has 1 set of lone pair electrons and 3 unpaired electrons. Whereas when oxygen was neutral, it had 2 sets of lone pair electrons and 2 unpaired electrons. Neutral oxygen likes having 2 bonds. Positively charged oxygen likes having 3 bonds, so it changes the bonding properties. So now that we see what oxygen looks like in a positive state, then we go ahead and combine the rest of the Lewis symbols for the other elements and form our Lewis structure. So here we have our positively charged oxygen. We have 3 additional hydrogens, each with 1 valence. We get rid of the unpaired electrons by combining them to turn into bonds. And then we see the Lewis structure of H3O+. And just as a reminder, it's very important to always label charged species with either a plus or a minus inside of the Lewis structure. So if I was to leave this plus out, technically this would not be a correct Lewis structure. I need to indicate that this oxygen has a positive charge. So we can still do our electron count, but we need to remember that we have removed one of the electrons. So here, if I do the electron count, we have 3 hydrogens, all with 1 valence electron, plus an oxygen with 6, but remember we removed an electron to give it a positive charge. If we add this together and divide by 2, it tells us our answer should have 4 electron pairs, and we can see that our answer does have that. Likewise, when we look at the Lewis structure for H3C-, we are going to give the carbon a negative charge by adding an electron to it. So normally carbon has 4 valence electrons. By adding an electron to it, it becomes 5 valence electrons. And once again, by changing the charge on an atom, it changes its bonding properties. Neutral carbon likes having 4 bonds. Negatively charged carbon likes having 3 bonds. Once we assign a charge to our individual atom, so we have a negative charge on our carbon now after we've added an electron, we combine with the rest of the elements. So here we have other hydrogens, each with 1 valence electron, each with 1 unpaired electron. We get rid of the unpaired electrons by connecting them to form bonds. We remember to indicate that this carbon has a negative charge. And once again, we can do the electron count. To make the negative charge, we have added an electron. So we start with 3 hydrogens, each with 1 valence electron, plus a carbon which had 4 valence electrons, plus we added 1 more electron to create a negative charge. Add these together and divide by 2. It says our answer should have 4 electron pairs, and our answer has that.